Welcome back to another module of Advanced Analytics for Executive Leadership. I'm Dr. Elizabeth Cook. Today we are going to jump into the conversation or the language we choose within pilot design and feedback loops. So really becoming more comfortable with the idea of starting small, validating assumptions, this whole idea around tracking bias and accuracy, not only with data, but with the folk and the people that you work with. And lastly, embedding these feedback cycles and or process implementations to ensure the pilots are effectively being executed and then assessed. As with the past modules, I want to ground our first thought in critical thinking, really reminding us that pilots are not just small versions of big projects. They are learning labs. And so the feedback and or the themes that I have gotten over the last many years around utilities and embracing pilot projects as a way to navigate the regulatory and financial realms also has sent a essence or a culture about how utilities operate to the vendor ecosystem that it is a death by pilot. So it's important to really reframe or think of pilots with a lens of critical thinking, as the job is not to prove we were right all along and this is the project and or technology and or tool that must be used. It's to create the space to ask, when in action, what assumptions are we making and how can we test them quickly? Where could this fail and how will we know early? What does success look like? Not just for leadership, but for the people who will use this day to day. And then how will we collect honest feedback? And what will we do with it when we get it back? So there is a significant amount of language and or leadership training or executives and middle management, senior management, wanting to create space that is safe for the doers and the action-oriented to suggest and or inform or educate on where the gaps may exist. I mean, that's where true cultural reform begins, where the doers feel safe to express what works and does not work. So you could think of a design of a pilot and or multiple pilots is really starting to formulate a healthy culture around the idea of fail quick. When we critically think through the pilot design, we're resisting the urge to make it perfect before launch, which is an area that I think we as humans find ourselves in. Instead of focusing on designing something small enough to learn from and then fast enough to adapt. Those are all skill sets and or learned behaviors that occur when doing and or speaking of them in an idea formation. And I guess I will share from my experience when working on my research and then diving deeper and deeper into the specific area where I was being trained, it was a very underutilized muscle after 15 plus years in the industry. And I think the more we think about that and become aware of that, you don't know what you don't know. So once you start to understand there's our learning muscles that we don't typically use, well, how do you then begin to use them? You have to first know of them. So the idea behind this module is breaking down pilots with a different perspective than maybe the language or the buzz that has been created around pilots for the last 10, 15 years in the electric utility space. All in all, the lesson is truly feedback is the secret sauce. And quite honestly, why we ignore it. So if you think in every transformational effort, maybe you have taken personally or have been a part of internally at your utility that you're leading, the feedback is the most valuable input. And quite frankly, as human behavior has shown, underutilized. Just using your own personal self as an example, how often do we create habits as an individual of taking the time in the morning to be goal-oriented and track certain behaviors throughout the day and then stop and reflect on said behaviors to determine or account for any of those actions that may or may have not gotten you to your goal. Take that to a larger organization. Why do organizations ignore feedback? Well, fundamentally, a lot of the things or concepts or ideas that we reflect on personally, as well as organizationally, it's inconvenient. It will show up in the middle of a delivery schedule, or personally in the middle of a holiday season, or it's uncomfortable. It points to flaws in our thinking, which nobody wants to accept. They may be wrong very easily. And quite frankly, it becomes messy, especially if it's coming from multiple sources with different perspectives. However, feedback is the fastest way to surface what's working, what's not, and where adoption is stalling. Without it, we are just guessing. I want to take us back to the concept of the electric utility mantra. This is how we've always done it. If you think about the history of the power grid, the people that were in charge of determining the ultimate design and were effectively the ones that created the foundational pillars of the power grid we know today were also the financiers, as well as the engineers, scientists, and tinkerers. The concept that they were in the machine shops building the technology to perform a certain action, it was very close to the financial and or decision makers. So decade after decade, if you lean into the history of how the grid developed and where it went and how it went, you will see very quickly a drop in the tinkerers and the developers and the designers in the weeds with the financial decisions and the customer that was served. Because that's another parallel. Think about the original customers at the beginning of the concept of developing the power grid to serve multiples, were the large commercial and industrial customers were a part of the design and the workforce development to serve said railroad industry, steel industry. I don't know if exploit is the right word, but drive and expand the industrial revolution. So the customers and the utilities were one of its same. And as decades have passed on, that siloing has become a large gap. So when we think about pilots, how do we reformulate the ability to stand up a project and almost give permission to the doers, those that are not in charge and overseeing the financial realm and or the customer interaction, to really lean into the technical challenges that are being created by launching said pilot. So the real challenge is building that feedback loop that people trust. There is an enormous gap that has been created on who and when and how can others trust each other based on the technology that's available and ensuring it continues to perform in a safe, reliable, and affordable way to serve the customers. So that gap is created. So when we think about pilot projects, the language we use is important, making it safe to speak up and being visible when sharing, and embedding then those conversations into the continuous rhythm of the work is paramount. And it cannot be an afterthought. So an example, a simple one, this is an accumulation of many stories, not one particular. But think about the almighty dashboard. We have had the ability to create pretty exhaustive and or flexible dashboards in our industry for the last really 10 plus years. But the dashboard pilot that failed. Really, until one incorporated the users and or operators that rewrote it. We have been very accustomed at creating a great amount of dashboards, and quite frankly, if we dive down that rabbit hole, you will uncover really many processes that have yet to be defined. A dashboard for a project, let's say capacitor banks of a full system. It was created by a team that understood where the data was coming from and fundamentally understood what the data was saying, and then created a visual map board to determine that the capacitor banks are on or off, and then to extract certain pieces of information over time. So the technology was sound, the visuals were polished, and really the data feeds were in place. But within weeks of launching the application, there was zero adoption. And after doing due diligence, it was because the design of the visual dashboards were being driven by a group that determined that this is the information that is needed by the doers. So the information was technically correct, but it didn't align with the process of the doers and how they made decisions in real time. So it seems obvious after the fact. However, because of the expediency and now the ease of developing these dashboards based on the tools that have become available to us as individuals, there's a rapid creation, which then doesn't take into effect of the power of bringing all of the groups together, understanding the process, and then building it to their definition. It's actually very similar to the development of the original Power Grid, understanding how the various systems work together, then formulating and creating it from the bottoms up versus the space that we've gotten to from the top down. If you think about how did that particular shelfware and or dashboard that was sitting unutilized even became known to the leaders that are effectively the ones that gave permission to build. I'm not giving you the answer, but if you think about if the feedback loop of the pilot project initiation was formulated and confirmed by all parties before launch, you can see how that gap in really trust that ultimately became a reality because the operators did not feel seen and those that spent the time to create it did not feel valued, and now you're starting at a negative space for your next evolution. So it's very important to install the feedback loop of all users to the implementers, etc. So co-creation, the people who used it hand in hand with the people shaping it. The lesson here is how does one start small and smart, especially under this enormous amount of pressure to be the utility that uses AI. It's really important to ground your critical thinking on the right people in the right room and asking the right questions. We don't have to create an army, we just have to ask the right questions and or have a clear hypothesis. What do we believe will happen? Define success metrics. How will we know if it's working? A limited scope. What's the smallest viable test? And then of course your feedback plan. How will we collect and act on input? And then of course, I guess, an end date. Pilots should either scale up, pivot, or shut down, but never drag on indefinitely, which is another use case that I've seen pop up in my interviews and discussions. To think through, these are very common activities that may be occurring. And one thing I've found through my discussions and leaning into like why some work and others do not is knowing who to bring in the room and then how to fundamentally give them not only the accountability to perform said ask, but the authority to ensure others will do when requested by said collective. And also really important to have your subject matter expert of said use case in the room with the gravitas or an awareness from a cultural team leadership perspective that they understand the operations or planning or forecasting realm that this tool is being built in. Because if this activity is happening without that expertise guiding the hypothesis, the metrics, the scope, and the feedback plan, you are already set up for failure. With data and the development of a platform and or tools, there is a nuisance of what these analytics can or cannot be saying. And so there's some terms that, if not understood originally or at the beginning, can convolute and or create distrust throughout the process. So some of the terms such as bias, what does bias mean? Are our models, aka the models that are built based after this said tool is created, are they systematically skewed in a way based on certain outcomes or groups? You know, being able to know what that particular project's driving and then understand the bias. So for instance, the model may come in a bit skewed, but is there other elements or ailments or variables that can be managed to then enhance. But what does it mean to be biased? What does the idea of drift? Does your model become less accurate? That can be a space of distrust. But if the users understand how these models are developed and the data inputs and outputs, they can then build the trust that say it does become less accurate, working with the data folk to ensure it snaps back in line. But again, you have to have the trust between the teams and the understanding of what this data is doing and why it's doing it, so that you don't know what you don't know. So if you start to at least get an idea that there's reason behind some of this change, you can then ask or create the feedback loop to those that can help drive the change to adjust. I found I spent more time trying to wrap my head around why I was being questioned around the accuracy. It wasn't until I stepped back and learned the difference between to be precise or to be accurate and how it fits in the perfect realm. All that to say is these terms can get thrown around in a meeting where if you don't fundamentally understand the difference of the two or the creation of how they're being measured, it may instill a seed of distrust, or you just don't believe that the model or the algorithm or the tool that's being developed is accurate and therefore won't serve your need. So again, it's important just to be aware that these phenomena exist, kind of the basic definition. You don't have to be an expert in it, so that you then can create that bridge of trust between the data experts and then the business unit expert. Food for thought around the idea that a pilot without a feedback loop is just a proof of concept. So if it doesn't help you grow, and then a feedback loop without action is quite honestly a complaint box. It doesn't help you improve. So you must, when launching a pilot, let's pull away from the buzzwords that have attached to electric utility pilots in general and realize it's a combination of thoughtful design, deliberate learning, and an ability to adapt based on the outputs that are being created, which I also believe is an area of critical thinking, is understanding the phenomena of continuous learning and how you're always leaning in and determining, can we move a step in a different direction and or the same direction, but you have to be able to tune into that and be responsive to adapting. Like, you're never gonna have the perfect answer or the right or wrong. It's a flow towards progress. I think the last thing I'll remember for giving it over to Connor is the goal is not to prove you're right. And I was a little bit guilty of this. It's just discover what's true and then act on it. So Connor is going to take us deeper into the technical side of piloting and feedback loops, really the idea of how to design for bias, drift, accuracy, and then make some of that feedback actionable. Connor, the floor is yours.
Hi everybody, it's me, Dr. Valentine. Today we're going to be talking about pilot design and feedback loops and building a strategy for how we can convince others that your ideas are worth pursuing. So today I'm going to be using a metaphor that relates our analytics work to the concept of chemical engineering scale up, where we're taking an idea from spoken words up through the benchtop scale to a pilot scale and finally to a production ready design. The good news is that we're going to start doing this today. So today's theme is tangible steps to start scaling your idea. Now, I put a little AI generated picture of a bird getting pushed out of the nest because today you're going to actually be transitioning your ideas through the pilot scale pipeline. I'm going to introduce the concept of a benchtop scale idea or project, which is right here at the start. And this is a way to bolster your ideas from spoken word into something that visualizes what exactly you're talking about. So in the scientific world, a benchtop experiment is one, well, it's exactly that. It's one that fits on your benchtop, right? Using just a little bit of funds, you're able to demonstrate the core technology while visualizing very clearly to everyone that your idea works and that it's scientifically backed by the data. These can be as simple as a story, right? A little storyboard, maybe a slide, and it can be as complicated as a functional demo that really convinces people that this technology can fit into your stack. Now, a regular idea is something like, hey, we should build a one-stop data warehouse, or perhaps a dashboard to show these maps would be helpful, or we should add AI into our customer service toolkit so that we can better serve our customers. A benchtop idea is something like, here's a diagram showing how the new data will fit into our pipeline. Here's a mock-up of the dashboard we're gonna make. Here is a video where we do a little Wizard of Oz magic behind the scenes and fake it, but it communicates what exactly we're gonna be doing. The core theme is benchtop ideas convince you, the scientist, that the idea is gonna work. And it also convinces others to support, fund, and back the expansion into a pilot where you're gonna be using this in the real world. The goal here is to bolster your idea into a vision that can be quickly shared in just a few minutes or less. The value of this is you can get feedback immediately instead of theoretically, and you can gain support when people tell you, that's right, you understand my problem and this solution has a chance of working. So on the left, we have an idea saying, hey, we need a new automated ETL pipeline to aggregate our data into a nice, easy to use form. The typical response for this kind of idea is, this sounds like more work, right? Or someone else needs to do this, and it can really shut things down. But on the right, we have the same idea communicated in a nice visual map where you can show the problem and the solution in just one visual. And this is a much stronger way to convince people what you're talking about. This is the first kind of homework, is to do this today. This is just an idea list, right? I've shown a handwritten note. This is as complicated as it needs to be to start. You have all these ideas already in your head. Get them down onto paper. This is just a list that will show you which of your ideas are the quickest or most worthwhile to start scaling up. And the last thing I'll say here is writing things down makes them real. I tend not to use the computer because it can get lost in all the other files, whereas a piece of paper, it's on your desk and you're not gonna forget about it. So after you have your list, ask these 4 questions to realize how to start expanding this to the benchtop scale. So the first question is, what assumptions am I making that convince me this will work? For example, you can assume that the data is going to be in a certain format, or it'll be ready, or perhaps updated at the rate you need. The second question you should ask is, can I communicate this idea in less words or pictures? Now, this is an engineering exercise that I've carried with me since my undergraduate education, actually, where you take your paragraph, you take your report, read through it, and your goal is to reduce the number of words by any means necessary. And you're gonna do this multiple times until you just distilled it to the bare bones messaging. Now, the reason this is important is because people aren't gonna give you much time a day when you're just talking ideas. Shorten that pitch down until the very essence is all you have left. The third question, ask what data sources you're gonna need. This is an analytics course, right? So data is almost certainly going to be involved. Make a list of the data and assume it's gonna be there. List what you need and how you need it. For example, the frequency of updates might matter a lot. You might even have a question saying, I don't even know if this exists. Make a note and move on. The final 4th question, this is the one that you're gonna wrestle with a lot. How do I convince myself that this is technologically possible, right? Because before you convince others, you're gonna need to convince yourself. The answer to these questions is really going to define how involved your pilot is gonna be and how involved the initial work is gonna be. The core theme here, benchtop ideas, they show initiative, right? You're not just saying I have an idea, you've actually demonstrated that you've done a little bit of the background work to show that this is possible. This leads to getting buy-in a lot easier because people see that you're already doing the work, you're investing the time, you're thinking about it seriously, and you're visualizing it. Which leads us to the third point, which is show your vision instead of describing it. Showing people visuals is much more impactful than just talking to them. Here are some examples of what this leads to. The first one could just be a picture of a dashboard that you just drew up, or you're talking to some AI or something like that. It's just a nice visual to demonstrate exactly what you're gonna be building and how it will be used. A semi-functional demo is our second example, which can be very impactful when people can actually play with it and see how it'll fit into their existing workflow. And the third easy one is a diagram showing your existing state and where you're going next. A simple block flow diagram can go a long way at communicating how things are arranged and how things need to change for your idea to work. So once you have your benchtop scale ideas, you'll naturally start wondering, how do we go to a pilot, right? And an idea becomes a pilot when people are actually using it for their work, or perhaps alongside the old way of doing things so they can verify, hey, this is gonna work. Core difference here is that while a benchtop idea convinces you this is possible and that other people should buy in, the pilot convinces people that you've created a better way of doing something. So the comparison switches to comparing the old way to the new way. And now you're actually talking progress. So as you iterate, your portfolio of benchtop scale ideas will grow. You might have 1 or 2 at first, but in a few months' time, you might have 5 to 10 good ideas that you can quickly visualize, and naturally, one will start rising to the top as a likely pilot to get started on. The core difference here is that in a pilot scale, data and maybe live data is going to be used in some way in a real process at work. For example, your dashboard that shows a map of the next underground wires that are likely to fail is being used by your engineering team to, let's say, plan out the work for the next few years. It doesn't have to be the only way they're doing things, but now you have real people at your organization using your tool to try to see if the new way of doing things is actually better and worth scaling up so that everyone's using it. How do you actually know that your pilot is better than the old way of doing things? I am going to introduce the scientific way where you can pilot smart while building, I'm going to call it human momentum, which will naturally lead to scale up to production. At this stage, your benchtop idea convinced people that your idea is worth pursuing. And so now your pilot is going to be a fact collection exercise that builds a case for or against the expansion of your pilot. I think we need to talk first about what it actually means to be scientific, because that's kind of a fuzzy word that a lot of people don't actually understand. I'm going to introduce a motto from one of the oldest scientific organizations in the world, which is the Royal Society of London. In 1660, when they formed, their motto was "Take nobody's word for it." In the year 1660, this was a radical concept because this was the era of kings and emperors declaring fact. For instance, that the earth is the center of the universe, or that the sky is actually a dome above you. At this time, the authorities would just say, this is the way things are. And this society was formed with the intention of building up scientific understanding from data. And these experts would not trust each other. They're saying, don't take anyone's word for it, including myself. Let's start from the data. The only scientific facts we're going to acknowledge are ones that anyone can independently verify, starting from the data. This often comes across as being paranoid, and that's not the case. What you're doing is making your foundation of the data now, instead of just people's opinions or how they want things to be. And that's a radical transformation. And once you start down this path, you'll start questioning everything. Now I'm gonna show another quote from one of the Mythbusters guys, Adam Savage. And he said, the only difference between screwing around and science is writing it down. This was kind of a quirky comment he made, right, when they were exploding something on the Mythbusters set, but it actually holds really true. The first reason to write things down is for yourself, so that you can remember it, but also you're recording this for others, so that when people are resisting to change, you can, skip all the opinions and just focus on the data. This leads us to what you need to do during a pilot, which is the first thing is start small. Right? You're gonna need to find allies who think your benchtop idea is good and that it has a chance. So a pilot can be started with just one person saying, wow, that's a good idea. My team might wanna use that in the field, or my team might wanna use that to validate something else. The second thing you do during your pilot is validate assumptions. And this isn't just a hand wavy thing. You're gonna start from those assumptions that you wrote down alongside your idea list. Now, these assumptions aren't just milestones. They are questions that you need to answer with your data. This is the scientific method, right? You're assuming things are this way. That's an assumption until you prove it otherwise. The third most important thing, in my opinion, is to track the numbers. You might want to call this adoption or buy-in, but really, you're building a case that this new way of doing something is actually better. And this way, you're not just going to be wrapped up in the opinions and technologies and all that, and you're going to focus on the data. Now, the second part of piloting smart is acknowledging that your ideas are doomed without people to use them or who want to use them, right? You can try to force a person to use your tools in their job, but if they're not bought in, if they're not excited, you're kind of pushing a boulder uphill. The way to build human momentum is to include people as part of the team and to give them agency, to give them the power to speak up and to actually talk about their opinion. So these are 4 concrete tips that you should remind yourself of whenever you're engaging with a team that's going to be involved with your pilot. So the first thing is listen more than you talk. The success, right, of this pilot depends on the users and not so much you. So it's tempting to speak and talk over people, but it's more important to listen and ask questions because that's the scientific way. The best way I've found in my experience to get buy-in is describe someone's problems to them and wait for that's right. When someone says that's right, it means they're acknowledging that you understand their problem or the way they want to do things. It really is a point where you've shown concrete understanding and empathy. So get to that's right. It's as simple as it needs to be. Make sure everyone that you're working with has said that's right to you and that they know that you understand what they're going through. The third thing is get champions. These are users who are now, marketing the product, the pilot on your behalf. This is a good sign that your pilot is working, right? When people get excited about it, when people outside of the pilot on other teams might be asking, hey, can we use the tool yet? Is it ready yet? And more than you as the leader, saying it from the top, champions communicate from the bottom up, and this creates a very strong base to, showcase that your pilot, when you scale it up, is going to be well received, it's going to be useful, and it's, you're on the right path. Now, the fourth concrete thing is to stay humble, right? It takes a bit of confidence to move your benchtop idea, get buy-in, get it to scale up, get the engagement, and it's tough to stay humble. But you need to understand that the scientific method, you must accept that things could go wrong, that you could actually prove that your idea is not good. And it really is important to stay humble because throughout this whole process, you're going to be talking to expert users who know more than you do, almost certainly, about what their exact job is. Treat this as a chance to not only collect data, but to learn more and more and more to help turn over every stone that could be a problem when you scale from pilot to production. Because there are hidden traps, there's hidden pitfalls, and staying humble is a good way to get your users to come to you and say, hey, I think I see a problem. This brings me to an important point about collecting accurate feedback, right? In a scientific way. It's really easy as the boss, as the leader, to create an aura of intimidation. It's not exactly intimidation, but it's intimidating, right? Because you have users in the field who they see a leader come in, they're excited about a new project, they know it needs to change. They might feel like they can't actually speak up and say what they actually mean. There are lots of examples throughout history over big mistakes happening because nobody spoke up or people spoke up and weren't listened to, right? This requires that the users are motivated enough to care about the idea. Now, I'm showing a diagram here that shows just a bunch of business leaders talking about the same idea, and it's going down the chain, kind of in a game of telephone, right? Now, this game for kids, right? It's funny because with just a few passes down the line, the message can be so distorted that you've completely missed the point, right? You're in a whole different ball game. And this happens at your organization. Collecting feedback, it's important to skip this chain whenever you can, go directly to the source, and prevent as much of this game of telephone as you can. But this does require that the users trust you, that they can actually speak up, and that their voices will be heard. They need to be part of the pilot, and they need to feel ownership. Okay, so I'm gonna expand a little bit to communicate just why collecting feedback is not simple. Communication is an emotional game of telephone in the corporate structure, right? It goes from the user up the chain, and there are 4 points of failure at every time that two people are talking, right? The first point of failure is when the person is translating their thoughts into words, right? A person might be using a little bit different language than they're used to, especially if they're from a completely different job. Now, the second point of failure is the spoken words. A person might stumble, they might say the wrong thing. They might say it in the wrong tone that comes across as angry or upset. Now, the third point of failure is the person hearing it, right? The other person's gonna hear it. They can get that wrong and perhaps take in a message that the person didn't understand. And the fourth point of failure is what's going on in the other person's head, right? So anytime two people are talking, which is collecting feedback, there's this chain that your message has to survive to accurately collect the feedback. Now, it's really important to not take this for granted because when you're going through the process of scientific data collection, you're gonna really want a certain answer. And it's really important that you clarify and really understand what that feedback really is, because there could be a hidden meaning or the meaning could get lost. And once that happens, you no longer are collecting the data that you thought you were. To cap this off, I'm just gonna go over the difference between benchtop ideas and pilots. And hopefully this will help you as you're hauling those ideas from your written list into the production level. Benchtop ideas, they convince you that your idea is gonna work, and they convince other people to pay attention and give you the resources you need for a pilot. Once you're in the pilot stage, you're no longer convincing people. You are comparing your new way of doing things to the old way of doing things, and that's a scientific exercise. When you get to the pilot, you're gonna be collecting data that compares the new workflow to the old workflow. You're also gonna be collecting feedback from users. Will be spoken word, this could be written, but it's still data. After you've gone through this process, you're gonna be ready for production. This will be a very natural transition, right? Because you've already collected the data in the field, in a production setting, and hopefully by now, you have some champion users who are really gonna help you expand, teach other teams, and lead to those better outcomes that this whole course is about. So thank you for listening today, and I'll see you next week.
Thank you, Connor. That was great. The next step is I'll launch a few thought exercises for you to think on your own and or maybe engage your organization. So the questions are, when was the last time you stopped to define a hypothesis before launching a project? So maybe not particularly you, where you actively engaged in that activity. And then personally, have you stopped and thought about a certain project with a hypothesis in mind? Are your feedback channels, which is your people, robust enough to surface issues quickly? It's a form of trust. Do we have, or you have, a culture that sees feedback as a gift and not criticism? How do you monitor a pilot or a solution once live? And then just remember, these questions really aren't about a particular pilot. They are for you to build the muscle of continuous improvement. So with that, see you at the next module.